Uh, Good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be discussing this morning will be an electronic component, component that rectifies alternating current to direct current, AC diode. And one of the configuration of a diode is actually a bridge diode. Bridge diode meaning there are four diodes inside a physical thing of an electronic component like this one here. This is a bridge diode. So normally for a single diode which is not bridge, there are only two terminals. It is just something like this, a long one, first terminal, second terminal. But for this bridge diode, there are four terminals. And for this diode here, actually the serial number is KBU2510. You could Google this one and it will bring us the pin diagram of this one. Anyway, the four terminals here are actually marked with the proper markings. The first one is the negative terminal. Second one is line number 1. Third one is line number 2. And the fourth one is actually the positive terminal. The negative and positive terminal is actually where we place our DC load. And for line number 1 and line number 2, that's where the input alternating current comes in. Okay? For us to easily check if the diodes inside are good or bad, we must have to draw the circuit diagram of this one. And I've been a professor for quite some time, so I could do this one even though I'm eating or anything. That's the drawing or schematic of a bridge diode. There are actually 4 diodes inside. Okay, I will try to discuss this one, okay? I will put it down, then I will try to read it like this. There's line number 1, there's line number 2, then there are 4 diodes inside, and they're interconnected, right? Okay, I will try to give you the components when the positive alternation will come out. When the positive alternation will come out, line number 1 will be positive. So the alternating current will be emanating from line number 1. It will pass through diode number 1. It will pass through the load. It will pass through diode number 2. Then go back to line number 2. That's for the positive alternation. For the negative alternation, when the current reverses direction, line number 2 now will be positive. So the current will be emanating from line number 2. Okay? It will pass through diode number 3. It will pass through the load. Okay? It will pass through diode number 4. Then go back to line number 1. That's the components in which the negative alternation current will pass through. And if you try to notice it, for both the positive and negative alternation, the current always emanates from the positive terminal. It will always enter at the positive terminal, then through the load, then go back to the negative terminal, like here. So there are 2 arrows here. The first arrow is the positive alternation current. The second arrow is the negative alternation current. So for both the positive and negative alternation, the current passes through the load in only one direction. That's why we could say that the current passing through the load is direct current. It does not alternate. How come it does not alternate? Because for the negative alternation, it's reverse bias. It could not pass through current. A diode will only pass current when it is forward bias, meaning to say its anode is positive with respect to the cathode. Okay? How do we check if the diodes inside are correct or not? Okay, try to memorize this, guys, the figure first, then I will bring it down. Okay, so I could demonstrate how we will what do you call this, check the four individual diodes. For a diode to be checked by using the tester here, we place it on the diode thing. We change the mode. There's a diode mode already here. So there will be two terminals. So to check a diode, the positive terminal should be connected to anode and the negative terminal should be connected to cathode. And there should be a reading which is less than 1 volt. Just think of it that the positive terminal of the tester should be connected to the anode, okay, and the negative terminal to the cathode for it to be reverse bias. For the reverse bias, there should be a voltage drop which is less than 1. So on the diagram, if we try to check for D1 now, okay, we place the positive terminal on line number 1. Line number 1 is actually the second line. Okay? And if we place the negative terminal on the positive side, okay, positive terminal on line number 1, negative terminal on the positive terminal on the network, okay, there should be a reading. There should be reading. Oh, sorry for that. There should be a reading. The reading is 0.485 volts. That's fine. That's the forward voltage drop. That's fine. This reading here indicates that diode number 1 is fine. To check for diode number 2, okay, we change the location of the positive terminal. We put it on line number 2. So if we put it on line number 2, we maintain the negative terminal on the positive terminal of the network. We will check for D3. So if I will try to place this positive terminal on line number 2, line number 2 here is number 3 terminal. The reading will still be, it's not 0.489, it's 0.490. They are almost the same. Okay? The positive terminal is now on line number 2, so we are checking actually diode number 3. Okay, we place the positive terminal on line number 2, the negative terminal on the positive terminal on the network. We check for diode number 2, and what comes out is 0.489. So to check the last remaining diodes, the remaining diodes here will be D2 and D4. We are done with D1 and D3, right? So we will check this one. So we interchange the terminals of the tester. To check diode number 4, okay, we place the positive terminal of the tester on the negative terminal. Okay. Then the negative terminal on line number 1. Line number 1. Okay. The voltage drop, forward voltage drop of D4 is 0.490. Okay. What we did is this one. We put the positive terminal of the tester here and the negative terminal on this terminal here, line number 1. We will be checking for D4. And the value voltage drop of D4 is 0.49. And to check this, the last remaining diode, it will be D2, right? So we maintain the negative terminal to be connected on the positive terminal of the tester, and the negative terminal will be on line number 2. Line number 2. Okay, so we are done now with line number 1. Because for line number 1, we are checking for D4. We place the negative terminal on line number 2. We will be checking D4. So what comes out is still 0.489. Okay? So the 4 diodes individually got a voltage drop of 0.489. Actually, I will just show you the last one. We'll try to reverse direction. We'll try to see if there is a voltage drop. Okay, I will interchange the location of this one. The last one, the D4. Let's try to see if the diode will conduct. The diode will not conduct. It's an overload. It's an open circuit. Meaning to say, in the reverse direction, the diode will not conduct. That's why diode is just an electronic component which passes current in only one direction. That's why its main purpose is actually to rectify alternating current. It will only pass current in one direction, that is in the so-called forward direction. In the reverse direction, it will not pass current. This is the reverse check of diode number 4. The last three, or the first three, it will still be the same, but I will not show you anymore. Okay, that's it, guys. That's how to check the individual diodes inside. But to check the individual diodes inside, we must have to bring out the correct diagram. And we should know how the current passes through the individual diodes as the positive alternation will come out, and so with the negative alternation. Okay? That's it. Good morning from Los Angeles. This is Professor David J. De Los Reyes. I have shown you the diagram, internal diagram of a bridge diode, plus the way and how to individually check each diode inside if they are good or bad. Okay, good morning from Los Angeles.